Good day, ma'am. I am Michael Nene, and here is the lab task. I will show you how it functions. And before we proceed to the main circuit, which is this one, I would like to show you the decoder. This decoder is built the uh, with the truth table, which I have created, and I will show you the truth table just for a second. And changing screen to here, and there we go. In the truth table, we have 3 inputs and 7 outputs, and this is the outputs here. Thus, results into this. I will switch the view to here. The truth table resulted into this one, and the truth table that is created into a decoder was used here. And what I did here is I created 4 buttons, which is derived from my name, my last name, which is Nene, and created uh, 3 OR gates. And then this is the decoder, and this is the 7-segment display. In the task, it is said that uh, the task tells us that the letters to be encoded are only the vowels a, e, o, u. Whenever a vowel is switched or pressed, it will be encoded into binary equivalent. For A is 000, for E is 001, for I is 010, for O is 011, and for U is 100. And if it is a consonant, it will be decoded as C. And back to the circuit here. Uh, First things first, letter N. Since it is a consonant, its binary output is supposed to be 111. So I have connected the letter N to the 3 OR gates. The 3 OR gates is uh, is the 3 digits of the binary output. So if we click N, it is the output will its output will be C. Next, letter E. For the letter E, since it is a vowel and it has a binary equivalent which is to 001, I have connected the E to the third OR gate. I have connected it here because this will be the 0. The first gate is 0, then the second gate is 0, and the third gate is the 1. Since I have put it here, which results into this one, E. We have satisfied the binary equivalent, which is 001. Therefore, we have an output of E. The same goes for here, which is letter C because it is consonant, and here E because it is vowel that has a binary equivalent of uh, 001. And another thing here is I've created another name, which is my second name. I mean, my first name, Michael. It is long, so I use another uh, circuit here. And again, in the rules, the consonant should be have a binary equivalent of 111, and its output will be letter C, which is consonant. In this circuit, as you can see, I have connected M into three various OR gates, which is this one, and this one. You can see that if I click here, I've connected into the three OR gates, which resulted into C. And then for the letter I, the letter I has a binary equivalent of 0, 1, 0. Therefore, I have only connected the input into the middle OR gate. As you can see here, it has an output of I, and the only wire that is glowing is the middle part. And C, since it is a consonant, here is the flow of the circuit. I have connected it to the three OR gates, and it has a output of C. And the same goes for the H. Here, there we go. It is consonant. And for A, since A has an output of 0, 0, 0, it's like you don't have an output. So what I did here is I connected letter A to a AND gate that has a ground. Here, as you can see, we can see a ground here. So it will not affect the display output, which is A, because it is A here and an output of A, so why bother? Then for the E, since it has an binary equivalent of 001, it is connected to the third OR gate, and last but not least, the letter L, it is connected to all the OR gates. And before I end this video, I would like to show you I have created another uh, task just like that, but I used an IC instead of a gate. Uh, I will change the screen here. It is lab task. And there we go. This is the lab task. I used an IC gate instead of I used IC. As you can see here, we have a lot of IC here instead of this is the uh, IC that I used. I used an IC instead of the gates. It also functions the same, but the difference is I used a IC. The decoder is also the same as this is the decoder, and it also functions the same. As you can see, N is a consonant, therefore it's an output of C. E is a vowel, therefore it has an output of E. And also, explaining this, since we have a output of 001, I have connected it there. This is the input. And the same goes for letters N, C, and the same goes for E. That will be all for this video. Thank you for listening.